In this video, we are going to cover the CPM Algebra 2, Lesson 112, Day 1 Review and Preview problems, which are problems 112 through 118. So problem 112. Junior is saving money in his piggy bank. He starts with 10 cents and adds 2 pennies each day. Create an XY table and a graph for the function for which X represents the number of days since Junior started saving money and Y represents the total money he has saved. So we're going to create a table and a graph. So I have a table and a graph here. So I find it useful to first label the axes on the graph, then create a table, then use that to scale the axes, and then draw what we get. So we know X is number of days. So the x-axis is the horizontal one, so we're going to write number of days down here. And the y-axis is amount of money, total money saved, so we're going to write down the side. Total money saved. So when you label axes, try to stay as close to the wording in the problem as possible. So now we're always going to start with x equaling 0. So when we have x equals 0, that's the starting amount. So how much money did Junior start with? He started with 10 cents. So on day 0, he starts with 10 cents. And every day he adds 2 pennies. So after day 1, he would have 2 more than 10, so he'd have 12. After day 2, he'd have 2 more than 12, so 14. Day 3, he'd have 16. Day 4, he'd have 18. So using that, let's scale this. So we're going to let this be 0. And it looks like we're counting it by 1 day, so we'll let each line on the x-axis be 1. So it is not necessary to label every mark, so that's 5. And 10's right here. On the y-axis, we count up by 2's, so it might make sense to count up by 2. So 2, 4, 6, 8, 10. Here's 10. Then 2, 4, 6, 8, and that would be 20 up there. So I kind of view how my x and y's are changing and then use that to determine a scale. So now remember, he's every day, so one time a day he's putting in pennies. He's not continuously putting in money. That's important. So what this will be is on day 0, he'll have 10 cents. Oops. Okay. Then on day 1, he'll have, so essentially what will happen is for the first day, for the first day, he'll have 0 to 1. So that entire day, he'll have that. Then on day 1, he'll have 12. So he'll start, so on day 1, actually let's back this up. It should be the other way around. So get rid of some stuff here. Okay, so this is 10. So days, he'll have 0 there. Then on day 1, he'll have, let's see, this will go out to here, be an empty dot here. There we go. Then on day 1, he has 12, empty dot. Day 2, he has 14, empty dot. Day 3 has 16, empty dot. 18, and then we can go up to 20 like that. So this is going to be a step graph. So again, because throughout the entire day, so 0 to here, that's all. Day 1 doesn't start until this line. That's why it's a bar from 0 to the start of day 1. Then it changes. We don't connect the dots. That would imply that he's continuously adding pennies throughout each day. So this is another example of a step graph. Okay, 13. Use the zero product property in factoring when necessary to solve for x. The math notes box for lesson 114 may be useful. So if you have this textbook or ebook, you can go ahead and look at the math notes. We'll get to that in a later video. But we're going to review some important ideas in this course, which you will need to be able to solve these equations by factoring in this property. So in problems A, B, and C, notice that we have products equaling 0. So the zero product property says, we'll write that down here, that if A times B equals 0, then that means either A is 0 or B has to be 0. So how that factors into here is on part A would be x plus 13 and B would be x minus 7. So for this to be true, x plus 13 has to equal 0 or x minus 7 has to equal 0. Because this is in factored form. Factored form is when you have products, expressions as products equaling a number. And so since that equals 0, we use the zero property of these equations and we solve. So what plus 13 equals 0? Well, that would be negative 13. What plus minus 7 equals 0? Well, that would be positive 7. So part A, we get negative 13 and 7 as the solutions to the problem. Part B, same idea. We have factors, expressions being multiplied, and the product is 0. So this is where we use the zero property. So according to that, either 2x minus 3 equals 0 or 3x minus 7 has to equal 0. So let's solve the left one first. So we'll first subtract 3 and then divide by 2. Okay, at this point in this course, we want to try to leave our answers in fraction form. So one answer is negative 3/2, and then on the second equation, we're going to add 7 and divide by 3. And the other answer is 7/3. And 7/3 is a repeating decimal, so we do not want to round or use repeated decimals in our answers unless prompted. So the answers here will be either negative 3/2 or positive 7/3. In part C, x times x minus 3, that's still the zero product property. So we're going to take the x, that's a factor, is either going to equal 0 or x minus 3 equals 0. So x equals 0, that is an answer. So we don't have to solve that. This tells me that when x is 0, this will make this equal 0. The right equation will add 3 to both sides. So the answers here are 0 and 3. So on problems D, E, and F, they are not factored. They are written as sums. So we are going to factor them. And so this is a really good review of some ideas we need to be able to do. So in part D, notice how both terms have an x in common. So we're going to factor by pulling out the greatest common factor of those terms, which is an x. And then we're going to divide each term by x, get the leftover stuff in the parentheses. So x squared divided by x is x. Negative 5x divided by x is negative 5. And so now we have a problem similar to C. We solve with the zero product property, so set the factors equal to 0. Similar to C, x equals 0 is a solution for D. Then we'll solve the second equation, x minus 5. So what minus 5 gives you 0? That's positive 5. And so the solutions to this problem are 0 and 5. So in part E and F, we have quadratic trinomials. So to solve those, we can use an area model. And so I'm going to use an area model exclusively in these videos at the start because this curriculum really emphasizes them. So this is how I make an area model to factor. I take the first term, the x squared term, put that in the top left-hand corner of the square, of the rectangle. I take the constant term, a negative 35, put that in the bottom right-hand corner. And so what we want is we want two numbers to fill in these boxes. They have to multiply to equal the first number times the last number, which is negative 35. Have to add at the same time to give you the middle number, the b value of negative 2. So what two numbers do that? Well, that's negative 7 and positive 5. But the middle, these two boxes have to add to be the middle term, so they always get a variable shoved next to them. And then we're going to pull out the GCF of the first column. So x squared and 5x, they share an x in common. Now in Algebra 1, we learned this is actually a multiplication area model. So we can actually use multiplication to fill out the other GCF. So we start with x. X times what gives you x squared? Well, that's x. So the other x goes there because the length and width of that square should give me the product inside. So if at the top x is still there, x times what gives you the 5x? Well, that's plus 5. Then if this x on the left is really right, x times what gives you negative 7x? Well, that's negative 7. And I check. Does negative 7 times positive 5 give me negative 35? Yep, that's right. So this in factored form is the top expression times the side expression. Then I can use the zero product property to set each of those factors equal to 0. What minus 7 gives you 0? Well, that's positive 7. What plus 5 gives you 0? That's negative 5. So my answers are negative 5 and 7. Okay, last one. So I'm going to make another square over here. Okay. So this time I'm going to have 3x squared on the top left, negative 5 on the bottom. So same rules. I need numbers that multiply to equal 3 times negative 5 or negative 15. They still have to add to equal the middle number, which is positive 14. So the two numbers that do that are negative 15 and a positive 15 and negative 1. I need a sum of positive 14. So pull the GCF of the left-hand column. 3x squared and x, well, that GCF is an x. X times 3x gives you 3x squared. That's why the 2x goes there. X times negative 1 gives you the negative 1x. And 3x times 5 gives you 15x. Is 5 times negative 1 negative 5? Yep, that's a check. That means I did it right. So my factored form is x minus 1 times x plus 5. So set those equal to 0 because of the zero product property. So solve this. I'm going to add 1 and divide by 3. That gives me 1/3. And here it has to be negative 5. And so my solutions here are negative 5 and positive 1/3. This is a big skill you need to be able to do in this course. So if you have a hard time with this problem, it'd be worth it to watch some other videos and do some extra reps of this. In the future, I'll make another video that goes over this process of factoring these quadratic trinomials a little more in depth. Okay, problem 14. Terry's project for the math fair was a magnificent black box she called a function machine. If you put 3 into a machine, the output would be 8. If you put 10 in, the output would be 29. If you put 20 in, the output would be 59. So it wants to know, what would her machine do to a 5? How about an 8 of 1? How about an x? Well, when you look at this, you get a 3 gives you an 8. A 10 gives you a 29. And a 20 gives you a 59. So it actually looks like if you take this x, you triple all the x's, and then you subtract 1, you get the corresponding y. Think about it. 3 tripled is 9, minus 1 is 8. 10 tripled is 30, minus 1 is 29. 20 tripled is 60, minus 1 is 59. So what happens with a 5? When you put a 5 in, well, 5 tripled is 15, minus 1 is 14. So you should get 14 out. How about negative 1? Negative 1 tripled is negative 3, minus 1 is negative 4. How about x? Whoops. Well, I triple x, I get x 3x, and minus 1, I get 3x minus 1. So write an equation for the machine. Well, it would just be y equals 3x minus 1. That's what's happening to every single function or pair in that problem. Okay, it says Nafisa graphed a line with a slope of 5 and a y-intercept of 0, negative 2. Find the equation for a line. Well, we know it's a line. We know the slope and the intercept. So I should be able to use slope-intercept form. So we talked about that at the end of the last assignment 111. We did talk about it in the math notes for the video for today's lesson, so go back and watch those if you need to. The slope is m, this value is b, so we just plug it in. Y equals 5x, and since b is negative, it'd be -2. Find the value of x when y is 0. So what we'll do is we'll take our rule, we'll let y equal 0, and we'll solve this for 0. So to solve this, we will add 2 to both sides, and we divide by 5, and so we get 2 over 5. So when x is 2/5, or 0.4, y is 0. Okay, 16. In each of the following equations, what is y when x is 2, when x is 0, and then it wants us to talk about where each graph will cross the y-axis. So let's let x equal 2. And so we're going to plug in 2 into the equation. Do this in our head. 2 times 3 is 6. 6 plus 15 is 21. So when x is 2, I get 21 for the first one. When x is 0, I get this. So 3 times 0 is 0, plus 15 is 15. And that should make sense because we know that the 15 slope-intercept form, that's my b. B is the y-intercept, and y-intercepts only occur when x is 0. And so where would the graph of each equation cross the y-axis? Well, y-intercepts occur when x is 0. So this would cross the y-axis at 0, 15. Okay. So for part B, same idea. So we're going to let x equal 2. So we get y equals 3 minus 3 times 2. Well, 3 times 2 is 6, and 3 minus 6 is -3. So you're kind of using what I did before. This is really y equals -3x plus 3. So 3 is b. So when x is 0, we would assume y would be 3. That's the y-intercept. And so that means the graph would cross at 0, 3 on the coordinate plane. Okay, 17. Carmichael made a function machine. The inner workings of the machine are visible in the diagram below or to the right. So we want this is the inner workings we care about. What will be the output in each of the following cases? So if 3 is dropped in. So essentially what that means is plug a 3 into this machine. So we see 2x in this case. So we're going to plug in 3 everywhere. There's an x. Now it's really important that you put things in parentheses when you plug them in, especially if you use your calculator to calculate these values. So when I put this in my calculator, 3 squared plus 2 times 3 plus 1, I get a result of 16 for part A. So part B, now we're going to do the same thing, but now we're going to put a -4 right here. Now, it's especially important that you put negative numbers in parentheses when you plug them in, especially if you're going to use exponents, because it matters in the calculator. So I go -4 parentheses squared plus 2 times -4 plus 1, I get 9. Okay, and then now the last one, -22.872. So we're going to do that with the decimal points here. Same idea, just a lot bigger number, but it's okay because the calculator can handle it. So I'm going to go -22.872 in parentheses squared plus 2 times in parentheses -22.872 plus 1. And I get 478, that's an 8.384384. If my calculator gives me a terminating decimal, doesn't round it or repeat it forever, I should write all the digits whenever possible. We want exact answers, or we want to start creeping towards being confident to always give exact answers when possible. Okay, last problem, 118. Does the temperature outside depend on the time of day, or does the time of day depend on the temperature outside? This may seem like a silly question, but to sketch a graph that represents the relationship, you first need to decide which axes will represent which quantity. So part A, when you graph an equation such as y equals 3x minus 5, which variable, x or y, depends on the other, which is not dependent, which is independent. So again, we talked about this the last lesson, that the y value is always dependent upon what we plug in for x. So the independent variable is x, since we can use any value to substitute for x. The dependent variable is y, since its value is dependent upon the x value used in the equation. Which variable is dependent, temperature or time of day, which is independent? So obviously, if you've lived in this life long enough, you know that the daytime really dictates how the temperature will be. Afternoon is usually warmer, morning and night it's usually colder. That's because we know how temperature and time work. In fact, trade secret, anytime time is a variable, time is always the independent variable, because no matter what you do, that second hand on that clock's going to keep ticking. So the independent variable in this case is the time of day, and the dependent variable is the temperature. And that matters because if I want to sketch a picture of the situation, I need to know which variable represents which axis so I can correctly sketch it. So we're going to do that. So here's our coordinate plane. So since the independent variable is time, we're going to write time of day. And this would be the temperature. Now I'm going to let this be right here. It's going to be 12 a.m. midnight, and this is going to be 12 a.m. again. And we know as we go throughout the day, this goes up, and then it's going to come up. It's going to peak at some point, and then steadily go down, 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 down. And then it's actually going to repeat itself. So it looks something like this. In fact, I should probably go like this and make it more like this here. Okay, it's not linear. Temperature does not increase at a constant rate all the time, but someday in the middle. So this right here would roughly correspond to 12 p.m. noon. Usually the temperature peak of the day between 12 and 2, somewhere around there. Gives me a rough sketch of how temperature works no matter where you live. All right, so we have covered every problem in this review preview problem set. If you have found this video helpful, please like this. If you enjoyed this video and like to get updates on more videos as I make them, please think about subscribing to my channel. Thanks.